All right. So next, we'll start straight lines. Okay. The next section that we'll be focusing on is straight lines. Okay. So when there is a relationship between two quantities like this, okay. Let's say you have two physical quantities, y and x. Okay. They are related like this. Y equals to some constant. Okay, this is a constant times the other physical quantity x plus or minus some constant. When you have something like this, we call this a linear relationship. Okay, when you have a relationship like this, here the x should have the first power on it. The power should be 1 for x, right? So if you have something like this, we call it a linear relationship. Okay, so when you just plot this, okay, when you plot this relationship in a graph, okay, like if you plot this relationship y versus x, okay, the relationship between y and x in a graph, remember you'll always get a straight line. Okay, you'll always get a certain straight line like this. Okay, so any straight line like this, right? So this is the shape of this graph. Okay, a straight line. So if you have a relationship like this, y equals to some constant value into the other quantity x, and with that you have added or subtracted another constant, right? So for example, we can take a relationship like v equals u plus at. Okay, so v equals u plus at. I'll take t times, sorry, so a times t plus u. If I rearrange this, v equals a times t plus u, right? So you can see the a is a constant, okay? A is a constant and u is also a constant. So the relationship between v and t can be taken as a linear relationship. And if you draw a graph between v and t, okay, you will get a straight line, right? You will get a straight line. V equals some constant into t plus u, right? So u is also a constant, a is also a constant. So the relationship between v and t is a linear relationship, and you can draw a straight line between v and t, right? So now we can uh, go into this. Now let's say if you have a relationship like this, okay, um, and as I said, we can draw a straight line. We can draw a graph which will be a straight line. So in this relationship, as I said earlier, you have something and you multiply it with x, and you'll have another constant that gets added or subtracted. This quantity that gets multiplied is called the gradient. This quantity is the gradient. And the quantity that gets added or subtracted is called the intercept. It's the intercept. So generally we use the letter m to represent the gradient, and we use the letter c to represent intercept. So y equals to mx plus or minus c. Okay, or we can just say y equals mx plus c, right? So now what we can do is we can just go through these relationships. Here they have given a few equations. So y equals 3x plus 2, y equals 7x minus 5, and so on. So looking at this, you should be able to identify the gradient and the intercept. We can see y equals to some constant 3 into x plus some constant 2. So this constant is called the gradient. and the other constant is called the intercept, right? Okay. Now, let's say you have a relationship like this. Now, in these relationships, you can easily find the gradient and the intercept. Only if I consider the e part, f equals 5x, 5 times x, and you don't have anything added. So let's say 0. Okay, nothing's added. Uh, so gradient will be 5 and intercept will be 0. Okay, right. So now if you have a relationship like this, let's say it says like this: 3y equals to 8x minus 4. If you have a relationship like this, 3y equals 8x minus 4, you can't say gradient is 8 or intercept is negative 4. You can't say that, right? So here what you have to say is, what you have to do is, first of all, you should take, you should isolate y. So you have y here, 3y here, but you have to leave y alone in that section. So you just need y there. You can't keep anything else. So you have to rearrange the relationship such that you get y only here. So this 3 has to be taken to the other side. So both these quantities, 8 gets divided by 3, x minus 4 also gets divided by 3. So now we can say what the gradient is. So gradient is 8 over 3 and intercept is negative over 3. Okay. That's the gradient and the intercept, right? So now let's try to understand what this gradient is. Right now we say this gradient and intercept. What's the physical meaning of this gradient and intercept, right? So you can see, if I have a straight line like this, okay, if I have a straight line like this, okay, gradient is actually the slope. Gradient actually represents the slope of the straight line. That means how much the straight line is sloped. Like what's the how steep is the straight line? Okay. So if someone asks how steep is the straight line, then the answer should be the gradient. Okay, you should be saying the gradient. So if the gradient is high, uh, then the uh, straight line is more steep, right? If the gradient is high, it's more steep. If it is less, then it's less steep, right? That's the idea. So more steep means the line would be like this. If the gradient is high, the line would be like this. And if gradient is less, the line would be like this. Okay. So this is one thing. And also the sign of the gradient, like whether the gradient is positive or negative, also has a meaning, right? If the gradient is positive, that means the graph is something that increases. The graph is increasing. Okay, this is now in these two I have shown increasing graphs. So here the gradient is positive. It's positive gradient, right? And also you can have negative gradient. Okay, you can have negative gradient that will be represented like this. If you have negative gradient, the line would be like this. Okay, the lines would be something like this. They'll be decreasing. You can see will be going down, right? On these lines you go up. Okay, you can go up like this. So here the gradient is positive. Here the gradient is negative. So negative gradient represents graphs that are reducing or decreasing, right? So that's the physical meaning of gradient. Gradient represents the slope of the curve, okay, of the straight line, and you can see the sign of the gradient also has a meaning. So if the gradient is positive, then it's an increasing graph. If the gradient is negative, it's a decreasing graph. Okay, so you should know this. You should know how the shape looks. Okay, if it is that way, if it is increasing like this, then the gradient will be positive. It has to be positive. Okay, and if the gradient is negative, or if the straight line is like this, the gradient is negative. Okay, so that's one point. Another one is about the intercept. Now the intercept is the y value, or we actually say we have to say that as y-intercept. Okay, though we just uh, take it as intercept, it's actually the y-intercept. Okay, uh, y-intercept. Y-intercept means the point where the straight line cuts the or intersects the y-axis. This is the intercept. Okay, the point where the straight line intersects the y-axis is the y-intercept, right? So you can see uh, if it intersects at a positive value of y, the intercept will be positive. If it intersects at a negative value of y, it will be a negative intercept, right? So that's the idea. So if you have a straight line like this, here the intercept is negative. C is negative because it intersects the y-axis at a point uh, below the x-axis, at a point where the y value is negative, right? So in a straight line, okay, now if you take a straight line, we can find the gradient of the straight line using this relationship. M equals y2 minus y1 over x2 minus x1. Okay, we can use this relationship to find the gradient. Okay, y2 minus y1, x2 minus x1. What does it even mean? Right? What does this relationship mean? It is like this. Let's say you have 2 points x1 and x1 comma y1 and x2 comma y2. These are the coordinates of uh, 2 points on the straight line. Okay, so 2 points on the straight line. So for example, let's say I have a straight line like this. Okay. So let's say I have a straight line like this. The coordinate of one straight line is 3 comma 4. The other straight line is 7 comma, sorry, the other coordinate is 7 comma, right? Um, so to find the gradient of this straight line, what we can do is, now the relationship is y2 minus y1 over x2 minus x1. So you choose one of these 2 points as x1 and y1. Okay, so I'll take this 3 comma 4 as x1 comma y1. I'll take the other one as x2 comma y2, right? So x1 comma y1, that's 3 and 4, right? So x2 comma y2 is 7 comma 9. So now we can substitute y2 is 9, right? And y1 is 4 divided by x2 is 7. X1 is 3. So 9 minus 4 is 5. 7 minus 3 is 4. So the gradient is 5 over 4. Okay. That's how we find the gradient. And in this question also we can see what they're asking is something like that. They've said that a straight line passes through uh, these two coordinates given. Okay, so you'll have to find the gradient. So I'll just do one of this. Let's take the D part. If you take the d part, I can take this as x1, y1, this as x2, y2. I can choose any of these two as x1, comma y1, okay, and x2, comma y2. So that is not an issue. Okay, so you can just choose anything you wish. So gradient is y2 minus y1 over x2 minus x1, which is 17 minus 7. y2 is 17, y1 is 7, divided by x2 is 8, x1 is 3. So 10 by 5, which is 2. That's how you find the gradient of a straight line. Okay. So now next, finding the equation of a straight line. So if they have given the gradient and intercept, finding the equation of a straight line is not difficult. You know the relationship is y equals mx plus c, right? I told you m is the gradient, c is the intercept. So you just write the relationship substituting these values for the gradient and the intercept. So y equals 5x, and for c it's minus 3, so 5x minus 3, right? That will be the answer. And let's say they have given the gradient and also they've given a point through which the straight line passes through. So when they have given something like that, for any straight line, the equation is y equals mx plus c, right? So now they have given the gradient. Let's consider the a part. So y equals to, the gradient is 3, so 3x plus c, right? And they've said that the straight line passes through 2 comma 7. So 2 is the x coordinate, 7 is the y coordinate. So I'll just substitute that here. Y equals 7, right? 3 times x is 2 plus c. So I just substituted the x and y coordinates into that equation. Y equals 3x plus c. So y is 7, x is 2. So 7 equals to 6 plus c. So take 6 to the other side. C equals to 7 minus 6, which is 1. So the intercept is 1. Gradient is given as 3. So y equals to the equation. Okay, the equation y equals to 3x plus, instead of c I can put 1. So this is the equation of the straight line. Okay, so that's the idea. So we can try the other questions. So here they have given two graphs. Actually, the coordinates are missing. Sorry. So we can say this y coordinate is, let's say it's 2. Okay, and let's say this coordinate is 6 comma 8. Okay, so let's say this is 6 comma 8 and this is 2. I mean the intersecting point is 2. You can see at this point x is 0, right? Here x is 0 and that's 2, so the coordinate will be 0 comma 2, right? So you can find the gradient using y2 minus y1 equals to y2 minus y1 over x2 minus x1. So y2 is, let's take this as y2, 8. This is y1, which is 2. 8 minus 2 divided by x1 is, x2 is 6, x1 is 0. 8 minus 2 is 6, 6 over 6 is 1. The gradient is 1. And the intercept, you can see that could be directly found. Intercept is 2 because it intersects the y-axis at 2. This is 2. So the equation of the straight line can be written as y equals mx plus c. M is 1, so it's just y equals 1 into x plus c is 2. So y equals x plus 2 is the relationship of the straight line. Right. So, so those are the stuff that we have to study under straight line. So if you can deal with this, then you can um, manage any question that relates with straight lines in physics. Okay. Okay then. So we'll move on to the next section.